Before we get started, are there questions on the homework? Questions on any of the homework assignments? You're welcome. All right. All right, guys. If there's no questions over the homework, so far, solving quadratics, we have found a few ways to solve. The first way, all right. All right, guys. So the first way we learned to solve quadratics was factoring. 2 sets of parentheses equals 0. Our second way was graphing. Because when we graph, we look for where it crosses the x-axis, and those are our solutions. The third way that we found was our square root method. And all three of these methods worked only on certain cases, because factoring worked as long as it is factorable. Our solutions are rational. Graphing worked, especially with the graphing calculators if they're integers. We could technically find rational solutions, but it took a little more work. Square root method worked if we didn't have a middle term or it was a single set of parentheses squared. Our first method that worked for all quadratics was our completing the square. This has been the first method that's worked for any and all quadratic equations, because it didn't matter what the quadratic equation was or how it was set up or what its solutions were, completing the square would work with every single quadratic equation. And we went over this in 3.5. We went over how to find the solutions by doing completing the square. And they had 4 main steps. Is A equal to 1? If not, make it so. The second step was to get the constant term by itself and leave 2 spaces. Our third step was find the value C so that it did become a perfect square trinomial, and then solve. Now, there is one other method that works for any and all quadratics, and that is the quadratic formula. Now, there is a specific way that we get this formula, or how it was arrived at, and that was from taking our general form, ax squared plus bx plus c, the general form for any quadratics with real values of a, b, and c, and solving this here using using our completing the square. Now I'm going to work through this here so that we get an understanding and foundation from where the quadratic formula comes from. This gives us a basis for it. You do not have to write all these steps down, but I would pay attention so we at least have an understanding of where this formula that we're going to get comes from. Because if we apply completing the square to it, it will give us a solution for any and all quadratics. Now the first step is a equal to 1. Well, no, we have an a value. So what we have to do first is divide everything by a. We have to divide each of these terms by a. So we're going to divide ax squared by a, bx by a, c by a, and 0 by a. Now our ax squared divided by a is just going to become x squared. Our bx divided by a is just going to be b over a times x, plus c over a is equal to 0. So that takes care of the first step. Our second step is to get the constant terms on one side. So, well, our only real constant term is this c over a, because x squared, b over ax are both terms with variables. So we'll have the x squared plus b over a times x plus blank is equal to negative c over a plus our blank. Bless you. Now at this point here, we do need to find the value of c, our third step. Now we do have some repeats in letters, but because this is our b over 2. Now in our case here, b is actually being taken the place of b over a. Now our b over a over 2 is really just b over 2a. And when we square that, we get b squared over 4a squared, because we're multiplying it by itself. And we plug it back in. About right, 2a, because it's b squared over 4a squared. Now again, being able to do this and do this step by step really doesn't matter. It's just giving us a foundation for how this works. Now the x squared plus b over ax plus b squared over 4a squared, all this factors because we still have x. And the number and sign inside the parentheses before we squared it was positive b over 2a. So this whole thing here, this x squared plus b over ax plus b squared over 4a squared factors down to x plus b over 2a squared equals. Now we do need to combine these here, and I'm not going to so much focus too much on how this ends up simplifying. But when we add those two together, we do end up getting b squared minus 4ac all over 4a squared. Now we got it in this form, we can take the square root of both sides. And on the left-hand side, our square root and square cancel. Telling us that we have x plus b over 2a is equal to plus or minus. We take the square root of the top, our b squared minus 4ac, and the square root of the bottom, our 4a squared. Now at this point here, we cannot take the square root of the top, but we can take the square root of our 4a squared, which gives us 2a. And lastly, to solve for this here, we would subtract b over 2a from both sides, really telling us that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And really, we can use this square, completing the square method, to find this equation, the quadratic formula. And this here is the other formula, or the other method for solving quadratics that works on all quadratics, no matter what our solutions are. Now our quadratic formula, really the key piece of information is this right here. Let a, b, and c be real numbers such that a is different from 0. And the solutions of the quadratic equation, ax squared plus bx plus c equals 0, come in this form here. So to use the quadratic equation, the first thing we need to do is get the equation equal to 0, find the values of a, b, and c, and then plug it in. Okay. Now let's look at our first example of this here. So we're given this equation, this x squared plus 3x equals 5. So for us to be able to use the quadratic formula on this here, we need to get this equation equal to 0. We need to get this equal to 0. So to get this equal to 0, what do we need to do? we need to minus 5 from both sides, which will tell us that we have x squared plus 3x minus 5 is equal to 0. So once we subtract 5 from both sides, we get x squared plus 3x minus 5. Now we need to find the values of a, b, and c. A is going to be the number in front of x squared, b is the number in front of x, and c is our constant term. So looking at this here, the value of a is 1, because it's just going to be the number in front of x squared. The value of b will be positive 3, and the value of c is negative 5. A, b, and c will not contain a variable. A will not contain x squared, b will not contain x. We won't have a variable in a, b, and c. We just have a number. Questions on how we got to this point so far? Now at this point here, we need to plug these values into a, b, and c in the quadratic formula. So we have first negative b, so we have negative. What is our value of b for this here? 3. So we'll plug 3 in for b. Plus or minus square root. Our first term is b squared, so it would be 3 squared minus 4 times a. Well, our a value is 1 times c, which is negative 5, all over 2 times a, which would be 2 times 1. Questions on how we got to this point here? Now at this point here, we need to simplify. Now, some of the simplifying steps we're going to be able to do in the calculator. Some of them we really won't need the calculator at all. First one we have is negative 3. Well, negative parentheses 3 parentheses. Well, that's just what? So this first part is just negative 3. Plus or minus. We're going to deal with what's inside the square root here in a minute. But the denominator, 2 times 1 is what? 2. So we can deal with the denominator and our negative 3 first, because our negative 3 is just, well, negative 3. 2 times 1 is 2. The next step, there's 2 ways we can go about doing it. One is we can do all this here by hand. 3 squared minus 4 times 1 times negative 5. The other way we can do this is we can take the 30xs and do 3 squared minus 4 times 1 times negative 5. Type everything that's inside the radical into the 30xs. Now, part of the reason we don't type the square root in at this point is on the off chance that what's inside that radical is negative. Because if it had been negative 29 and we typed the whole thing in, the 30xs would have told us it was a domain error. It cannot take the square root of a negative. But here we just get the square root of 29. Now at this point here we need to make sure and see if this does reduce. Because if the square root of 29 reduces, we need to reduce it. But does the square root of 29 reduce? No. Does the 3, the number in front of the radical, and the 2 on bottom have any terms in common? Have a greatest common factor between these 3 terms? Well, no. So, that there is the final answer. This is the solution for this quadratic equation. Questions on this here? We're ready for the next one. We want to solve 3x squared plus 4x equals 10. Now again, to solve these by using the quadratic formula, we need this equation equal to 0. So what's the first thing we can do? We can subtract 10 from both sides, which will tell us that 3x squared plus 4x minus 10 is equal to 0. Now, now that we have it equal to 0, we do need to find the values of a, b, and c, because once we have the values of a, b, and c, we can plug those into the quadratic formula, simplify, and we will get our answer. Now, the value of a in this case is 3, just the number in front of x squared and its sign, so it is positive 3. Our value of b, the number in front of x, is 4, and it would indeed be positive 4. And the value of c is negative 10. Questions on how we found A, B, or C? Questions on how we found any of this here so far? Now we need to plug our values in. So the first one we had is negative B, so it would be negative 4. Plus or minus the square root of B squared, so 4 squared minus 4. Let's focus up here. 4 times A, which is 3 times C, which is negative 10, all over 2 times A. So let's focus in. So the first thing we can simplify is our negative 4, which is, well, just negative 4. On bottom, let's leave that over there. 2 times 3 is 6. Now the next thing we can simplify is what's inside our square root, our 4 squared minus 4 times 3 times negative 10. Now we can do this by hand, or we can let the calculator take our 4 squared minus 4 times 3 times negative 10, which tells us that we have 136. Questions on this so far? Now at this point here, we need to see if we can take the square root of 136. And the square root of 136 is 2 square root of 34. So this does reduce, it does simplify. And since it does simplify, we will need to simplify it. Questions on this here so far? Now, is there a greatest common factor between our 3 terms? 2. So we can factor it out. There's different ways for us to see how this factors out. One of them is by taking and factoring the 2 out of the top 2 terms. And if we factor that 2 out, if I factor the 2 out, I divide the 2 out of -4, we're left with -2, plus or minus. If I divide the 2 out of our 2 square root of 34, the 2 factors out completely, leaving us with the square root of 34. And on bottom, we have the 6. Now, because we have it set up this way, we do have this 2 over 6. And 2 divided by 6 gives us 1/3, or a denominator of 3, leaving us with -2 plus or minus the square root of 34 over 3. The other way we can do this is just, well, we're going to divide each of these terms by that 2. -4 divided by 2 is -2. The 2 divided by 2 is 1, leaving us with the square root of 34. And 6 divided by that 2 is 3. Or the other alternative is we can pick the positive or negative case and use the 30xs and see if this reduces to -4 plus 2 square root of 34 over 6. And it does reduce. Our -4 becomes -2. Our 2 square root of 34 just becomes the square root of 34. And our 6 becomes 3. We could do the exact same thing, but instead of having plus, we have minus. And we get the exact same thing, but the radical is negative this time instead of positive. It's our plus or minus. Questions on this here are how we got to our answer. We ready for the next one? This one here is a little bit nice in that it is already equal to 0. We have x squared minus 6x plus 4. And all that means we don't have to do anything to get it into standard form to find our value of a, b, and c. We can go on and just get a, b, and c from the equation itself. So looking at this equation here, our value of a would be what? 1. Our value of b would be -6, and the value of c is +4. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So if we plug in our value of b, well, b is -6 plus or minus square root of -6 squared minus 4 times a times c, which is also 4, all over 2 times a. Questions on how we plugged in a, b, c? Now, there were some that asked if we could type this into the calculator as it is. The 30xs would work as long as what's inside the radical is not negative, because it cannot take the square root of a negative. So we could try typing this in, seeing what we get. -6. Now, we don't have plus or minus in the calculator, so we've got to pick one or the other. Square root -6 squared minus 4 times 1 times 4 all over 2 times 1. And we get this here. And go back and change the sign from plus to minus. We get the exact same thing, but instead of a positive square root, we get a negative. So this one here does work. It does simplify. And I will show you here the step-by-step way of how this works. So as we look at the first part here, negative, negative 6. The negative and negative would make a positive. The denominator, 2 times 1 is 2. Inside the radical, we have negative 6 squared minus 4 times 1 times 4. Negative 6 squared minus 4 times 1 times 4, which is 20. Now we need to make sure or check and see if the square root of 20 does reduce. And it reduces to 2 square root of 5. Questions on how we got to this here. Do all three terms, 6, 2 square root of 5, and 2, have a greatest common factor? Well, yes, they have a greatest common factor of 2, yes. If I divide the 6 here by 2, what do we get? 3. If I divide the 2 square root of 5 by 2, we get the square root of 5. And our denominator of 2 divided by 2 is 1. So the denominator we don't have to write, but just reduces this to x is equal to 3 plus or minus the square root of 5. Questions on this here? Questions on this so far? Are you ready for the next one? This last one on the first page is not equal to 0. So for us to start solving it, we need to set this equation equal to what? 0. And we can do that by what? Adding 7x to both sides, because our negative 7x plus 7x would indeed be 0. Telling us that 2x squared plus 7x plus 4 is equal to 0. So since we have it equal to 0, we do need to find the values of a, b, c. Well, the value of a is 2, the value of b is 7, and the value of c is 4. So our quadratic formula, x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So negative b, so we'd have negative, we'd plug in our value b, which is 7. Plus or minus square root, so b squared would be 7 squared. Minus 4 times a, which is 2, times c, which is 4. All over 2 times a, or 2 times 2. Now at this point here, we could type the whole thing into the calculator and see what we get, or we can do this step by step. If we do this step by step, the first part, this negative 7, would be, well, negative 7. The denominator, 2 times 2 is 4. Does negative 7 and 4 have a common factor? No. So most likely, is there going to be a common factor that simplifies in the end, like the last one? Well, no, because we needed to cross all three. It is possible for it to simplify, but it really doesn't make the equation simpler. At this point here, 7 squared minus 4 times 2 times 4. Parentheses 7, close parentheses, squared minus 4 times 2 times 4 is 17. You know what? While we're here, see if we can take square root of 17. Nope. That's it. That's as simplified as it gets. What do we think of the quadratic formula? Luckily for the quadratic formula, once we find the values of a, b, c, we plug them in and we go from there. Does that make sense? Tristan? Kinda? Yeah. I mean, there's not too much overall to it, because once we find a, b, and c, plug in, simplify. And the calculator, for the most part, does most of the work here. Yeah. I know we could do a few more, but we'll stop here.